here we go. So let's talk about Administrivia. I haven't used this iClicker tool before. I forget to start it and so forth. So you might check into that thing on the web page or your smartphone. Now that I have that up. Also, if we look at what's due when in the course shell here, I think I got a couple weeks up. So week 1. Some of these things you can still turn in. The thing in red, this is probably what some of you forgot about. Really, before now, you needed to have watched this. It's a half-hour long video. Again, there's a video bits link on the left pane of the course shell where you can find those videos. We're going to continue to talk a little bit of C++ now, and it's going to assume you've already seen that. So if you haven't, then there'll just be a little bit of catch up on your part. We're in week 2 now, so I have this visible, and I also got week 3 visible, so you should have the next 2 weeks visible. A couple notes. Assignment 7, I'm not going to do this semester. I didn't do it last year either. I think I may drop it, but for me to drop it properly, I have to rename Assignment 8, Assignment 7, Assignment 9, Assignment 8, and so on and so forth. And that, I'm lazy, so we'll just cancel Assignment 7 rather than be renumbering everything. Also, Labor Day quite frequently falls on the 3rd week. This year it fell this week. So Assignment 5, it's gonna be weird and seem jumpy. We're going to be doing Assignment 6 on Friday, and then the following Monday we'll do Assignment 5. So that's why the assignments are a bit wonky. So we have Assignments 5 and 6 out of order. Assignment 7 has been canceled, and so if the assignment stuff seems weird these next couple of weeks, that's why. There are quizzes that are due Wednesday. This week's quiz is actually not a quiz. It's just to keep cranking away on Vim, going through those tutorials and stuff. So no quiz you have to do. Once we hit week 3, you'll want to do that. Let's see. We have 2 labs. So even though we didn't have a Monday-Tuesday lab, there are 2 labs this week. Okay. Now the first lab is Hello World, which is to simply write a program that says Hello World. And if you watch the video bits, I believe, if memory serves, I actually wrote that entire program in the video. So it's really nothing more than transcribing what I wrote using, the Vim editor, and then going through that process of compiling the program and submitting it to that turn-in tool. So Lab 2 is nothing more than copying things. Lab 3 involves very simple input and output. We'll be talking about that today. And then note, before week 3, so before we hit Monday, there's another video that you should be watching. To repeat, these tend to be just content dumps, and it allows me to do more kind of in-class activities rather than lecturing all the time, so that's the reason for that. I'm happy to answer questions on them, but in general it covers content that I won't cover if you don't ask me to re-explain anything on those. What else do we have? Then Assignment 6, so this is Wednesday. I'll be talking today. Assignment 6 is going to be an activity in class, so make sure you have your computer with you. Did I say that right? On Friday? Today's Wednesday. I talk. On Friday we have the in-class activity, where will want your computer. I don't know if I've mentioned this before, so because I record all the lectures, they're a nice handy thing to go back and refer to. If I haven't said this before, the way I would take notes in this class is rather than scribbling furiously, I would simply, if I say something interesting or that you want to hear again, just simply note the current, just write a small phrase to kind of cue your memory and write the current time, because all these recordings do have the time of day up there in the upper right hand corner. And when you go back and look at the YouTube video, then you just simply slide to that point in time and watch 60 seconds around that rather than having to watch all 50 minutes. The other thing is I am kind of a slow talker, have a bit of a drawl. I would, if you ever go back to just want to generally review a video, I'd recommend, crank that thing to 1.5 speed. And then if I start saying things that are confusing and you need me to slow down, then go down to normal speed. I actually, nowadays, I'll prepare for class by reviewing a previous semester's lecture, and I always listen to that at 1.5 or 2 times. And then when I hear myself speak at normal speed, it like creeps me out. I can't believe how slow I talk. So anyway, with that, what else do we have? Since this clicker tool doesn't have it, I said before that I would post this. I have this note posted here in Piazza at the top, which is designed allowing you to ask questions if you want to ask them anonymously. And I'll try and check this throughout class and answer questions as they come up. Now that said, I certainly encourage you just to interrupt me and do the traditional raise your hand or interrupt me and ask the question. But I certainly understand people being a little bit apprehensive and wanting some anonymity, so that's why I give you this other option if you'd prefer that. Is there anyone who has this currently up on their screen? I just need a volunteer real quick. I need to see something. Let me know. All right, could you just type in a quick 5 or 6 words and hit post? Let me know once you hit post. Okay, you're very tired today. I sympathize with you. That's what I wanted to know. I didn't know if I'd have to refresh the screen or if that stuff would pop up automatically, and I'm happy to see that it pops up automatically. I'll just resolve those. How do I turn this on? Mission accomplished. It isn't anonymous, but when you're writing your discussion, there should be like a radio button or a checkbox to say post this anonymously. Yeah? Okay. All right. There you go. There you go. Result. Okay. Got that figured out. So feel free to post there if you have questions along the way. So let me, oh, my phone's letting me know of all these Piazza notifications. Do you have any questions for me now? Just that I encourage you to make eye contact and ask me in person. Any questions right now? All right. I guess Addison Bear is not the only one who's very tired today. Okay. So, what shall we start by talking about? Let's go here. How about this? The activity on Monday is actually going to exercise our use of creating directories and moving files around and things of that nature. But you've had a little bit of time at the command prompt. Are you having any questions on that yet that you'd like me to talk about? How to do this, that, or the other thing? Yes? How do you move a directory into a different directory? Excellent question. So let me create a directory called Papa Bear. And let me cd into that. Let me actually create. All right, so I've created 2 directories, Mama Bear and Papa Bear. And I want to, let me create. Now I've got 3. Now let's say that what I want is I want to put Mama Bear inside of Papa Bear, and then I want to put Child Bear inside of Mama Bear, right? So that it's one inside the other. So I can use move, and I want to move Mama Bear into Papa Bear. Now if I do an ls, we don't see Mama Bear any longer because Mama Bear is inside of here. And in fact, if I do an ls to see what's inside of Papa Bear, we see that Mama Bear's in there. Now, how do I move Child Bear into Mama Bear? I have to move the thing I want to move, and I want to move Child Bear into Papa Bear into Mama Bear. Now, I won't hit enter. If I hit enter, it'll actually do the move, but let me go ahead and add to that thought. What if I was up one, right? CD dot dot, what does dot dot represent? The parent directory. Okay, so now I'm in this directory called 111 F18. If I do an ls, we see that there are 3 directories here. The directory I was just in a moment ago was this one that ends in 905. So I can move inside of 2018-0905 Child Bear. I can move that into 2018-0905 Papa Bear, and that will do the exact same thing. So note that the command I actually give for the move, the files I specified, depends on where I am currently. I can literally be anywhere at all in the file system. I just have to basically say where in relation to where I currently am do I want to move these things. Now, to just give a final example there, if I cd into 2018-08-27, again, all this stuff's happening in 2018-09-05. So let me do a pwd just so you can see where I am. So I'm in this directory. The parent, 111 F18, has these 3 things in it, or these 4 things. So if I want to do the exact same move, I have to go up to the parent, which is 111 F18, and then down into 2018-09-05, and I have to grab Child Bear, and I want to move Child Bear into there. Okay. So again, 3 ways of doing the exact same thing. It all depends on where I am currently when I do the command. Any questions on that? Yes? Oh, yeah. Okay, so what I'm doing here is I'm actually canceling the command. I'm not actually executing the command. What the phenomenon is that anything that anything that you do here, ls, cd, whatever the command is, what else have we done? Vim, anything at all that your rm, anything at all you can type here, I can actually put into a file, and then I can run that file at a later time. And they're called shell scripts. It's a little bit beyond the scope of the class, but let me just. So I can cd into dot dot. I can move Mama Bear into Papa Bear. I can do an ls, and so on and so forth. So this is what I would call a shell script. These are all commands I can type there at the command prompt, but I'm able to put it in this file and then actually run this file as if I was typing the commands at a later time. For me to put a comment, so the pound symbol in the context of these shell scripts means a comment, which means totally ignore whatever comes after the pound, right? So what I was doing here is I was getting this command all set up, but I didn't actually want to execute the command. So what I did is I just went to the beginning, and I could have either deleted the whole thing, that would do it, but out of habit, I just simply put a pound sign there, which means that now it's being interpreted as a comment and it ignores it. A little bit, some of the things you've seen me doing seem to happen kind of fast. For instance, I go, so I was doing a move command, and then I type ch, and then all of a sudden all of this appears really quickly. That's what's being referred to as tab completion. This is to save you on keystrokes. So let me go let me go back. Okay, so here's where my starting point. I can, when I'm specifying any sort of file or directory, if I type 1 or 2 or 3 or just a few letters, I can immediately hit tab, and what it'll do is it'll look and see if there's anything in my example that begins with a CH, and when I hit tab it finds child bear, so it completes that for me. It's just called tab completion. If it doesn't exist, then I hit tab, so I type X and then I hit tab. There's nothing that begins with an X, so nothing happens. And if I can hit tab as much as I want, there's nothing to complete because the only thing it'll possibly complete are one of those two things. If they are named the same, so let me make a directory called child star. Oops. Now if I say ls.ch, I hit tab, it goes that far and then it stops because it doesn't know whether I want child bear or child star. So it's ambiguous, so that's where the tab completion stops. There are a couple options at this point. If I'm a little confused and I don't know why it stopped, I can hit tab a second time and it'll show me these are the two things I'm struggling with, and I can go aha, and I can finish it off myself. All I need is enough to make it unique again. So if I provide a B or an S, and then it becomes unambiguous what I want, I hit tab again and it completes it. Okay? So that's one time saver. There are a few time savers we can take advantage of here. Another is, you'll notice that I'm kind of zipping around, right? You're seeing this kind of thing, and you're seeing me do this and this and this and this fairly quickly. What I'm taking advantage of here is commands that I would normally use in the Vim text editor. So that's a real nice feature here that if you ran that helper script in that one of those early labs or assignments, that helper script sets up a few things. One of them sets up the ability to use Vim commands at this command prompt. Now, let me give you an example of that. Vim has two modes, a command mode and an insert mode. This kind of after the Labor Day holiday, this nightmare coming back to your memory, right? In command mode, anything you type is a command. In insert mode, anything you type is being inserted. I'm going to use those two terms. Right now, although I'm not in an editor, right now I would say that I'm in insert mode because anything I type is inserted into my command prompt. In Vim, how do I get into command mode? Escape. It turns out I can hit escape here at this command prompt, and that puts me into command mode. Anyone remember the keystroke to move to the left? H. Here I'm hitting H, L. How can I delete a character? X. See, I have all these nice. So once you get to know that editor, it becomes very powerful for editing your commands here. How do you go up? K. When I hit K here, I go up to previous commands. And does anyone remember offhand the keystroke to get to the end of a line? $sign. If I hit $sign here, I go to this line. Beginning of the line is 0. And then there are things I haven't talked about specifically, but maybe if you've started doing some of the tutorials you're learning, I can go W to go an entire word. I can do CW to change a word, right? Everything that makes the editor powerful you have here at this command prompt. So it makes things go a lot quicker. One other thing is executing previous commands. So let me I'm going to do some stuff really quick. All right, I've got a simple program here. This would have been seen in the video. There's an iterative cycle, something that you repeat when you're developing code. What you do is you enter the editor, you make some changes, and I'm going to forget a semicolon here. Again, it's not that important. I'm just introducing a bug so this thing doesn't compile. I quit out of the editor. I compile. What do I want to call this? And it won't compile successfully. I have a problem. So I go back into my editor. I make some changes. Who knows what the changes are? I'll make a change. It doesn't make any difference. I quit out of the editor. Actually, let me go back into the editor. I'm missing the third step in my, let me fix the bug. I quit the editor, I compile, I run. No, it's not running quite right. I wanted an exclamation point after hello world. So I go into the editor, I make changes, I quit the editor, I compile, I try running it, I go into the editor. So that's the cycle. Edit, compile, run. Edit, compile, run. Edit, compile, run. When you're writing programs, you end up doing this cycle dozens of times, right, depending on the complexity of the program. At the command prompt, I can speed that up with another shortcut. So we already know I can hit escape and then K to go up to previous command. So if I want to edit, I can do that. And then if I want to compile, I can hit escape KK, get up here, and do that again. And if I want to run again, escape KK, run again. But I can be even quicker in that there's a shortcut with an exclamation point, and then all you have to do is list one or more letters of a previous command that you did. So if I do an exclamation point G, that will run the most recent command that began with the letter G. In this case, G++. I can rerun the most recent command that began with the letter V. In this case, it'll be Vim. I can rerun the most recent command that began with a dot. In this case, running the program. Okay, so that's another shortcut to take advantage of. Right. Any questions on that? Okay. Just to make another dad talk is that I said last week that this is a 4-unit class. If you've taken the calculus sequence, the amount of time you put in to survive calculus is really what you need to put in for this course. Already, it's easy not to have watched the video. There is no actual quiz you need to take. I'm just encouraging you to continue to learn Vim. If you don't do any of that, I don't have any idea. I'm not grading on you looking at those references or you watching that video per se. But there are no shortcuts. It is impossible to cram this course. You can't. It's not like a history course where you can kind of cram enough to get through the exam. If you don't put in the time, you're either one, a natural and you're going to do great, or you're going to end up failing the course. Once you get behind, it's virtually impossible to catch up. So this course is a bit of a pain in that you have to be very self-motivated to put in the extra time. Okay. I imagine many of you, the command line's completely new. You've never heard of Linux before. You've never done any sort of programming before. And you feel like you've got maybe 10% of things going here and you're feeling a little bit unanchored and adrift. Okay, that's fine at this point. Be aggressive about using Piazza. Be aggressive about using office hours. Take the extra time to write a program. Here's something that with Lab 1, what you can do, and here's something I think you should do. With Lab 1 or Lab 2, whichever the Hello World one is, which I actually had created a version of right here. Okay. You can slowly struggle with Vim and eventually get this busted out and eventually get it compiled and submitted to Turnitin. If you're spending the right amount of time in this course, what you're going to do is you're going to say, okay, I'm going to do it again. This time I'm going to try not looking at your notes. And you're going to try doing it again, and you'll be just a tiny bit faster on Vim. And then you'll do it a third time. I'm going to sit down and do it a third time. You're going to do it, I don't know, 2, 3, 4 times until you can actually, one, bust out a program with a little bit of efficiency in the editor and have some confidence in these keystrokes, right? It's no longer a mystery that you need these parentheses here. You just kind of followed my video the first time. The second time you forgot these parentheses, look back at the video or your notes, put in those parentheses. Third time you remembered them, right? This is what I'm talking about spending the extra time. All right. Oh, Dad will get off his soapbox. So, nothing there. Let's go ahead and, in the remaining time, look at another program. I'm going to get rid of child bear, child star. Papa bear won't disappear. I should get an error. And the error is that Papa bear isn't empty. If I look in there, if we recall, I had moved Mama bear in there. There are a couple ways for me to tackle this. I could either remove directory. That'll get rid of Mama bear, and then I can subsequently get rid of Papa bear. It doesn't work so well if there's a ton of stuff in the directory, then you spend a half hour individually moving files. There is a shortcut. It's actually just the remove command. It has an option you can provide. And that option, let me not do the option. It complains, I can't remove Papa bear, it's a directory. You have to use the remove directory command. Well, if I use the remove directory command, it isn't empty, and that doesn't work. The R means recursive, which simply means go down into the directory and delete anything in there, and if there are directories in there, go down in those directories and delete everything in there. Okay, it'll delete everything in the entire hierarchy from Papa bear on down. Again, it's a programmer's operating system. If it's working fine, I get no feedback at all. And you can easily shoot yourself in the foot. There are wildcards. Nice one is if in your home directory you type rm -r star. That'll remove everything in my home directory on down. I don't want to do that. I will type slowly to make sure I don't hit enter by accident. So that's a good way to lose all your work right there. All right. So we have variables in mathematics. We could say x equals -23. We can say pi equals 3.14. We have variables, just as we have variables in mathematics, we have variables in the language. There's a difference, though. Let me actually create an error. I'm going to get rid of this hello world. I don't want it at the moment. I'm going to create, and then I'm going to take x, and I'm going to assign to it -23. Let me see if this program, now this program doesn't do much. It assigns -23 to x, and then the program ends. So there's really nothing to see. But I can still test the accuracy of my code, see that it's error-free by trying to compile it. So I'm going to do something fancy here so we can see this at the same time. All right, G++. What am I doing here? iocode.cpp-o ioprog. And try compiling that, and I get an error. It says use of undeclared identifier. Identifier is just a fancy word for variable. So it's saying it doesn't know what x is. This is a theme that I'll be saying over and over again, which is before you can use it, you have to tell the language what it is, or tell the compiler what it is, however you want to phrase it. Yes?
How do you split the screen into two like that?
Maybe I'll create a little tutorial lecture on the ins and outs of it. I will give you which is look up tmux, T-M-U-X. That's the tool you want to use. So again, you're not allowed to use it until you tell the language what it is. Yes?
So it says int main. Can you have it not return anything like void or whatever kind of like Java?
So that's an excellent question. So I don't remember exactly what I characterized this as in that video, but the language is a language where you build functions, very similar to how you build mathematical functions in calculus, right? You have f of x equals x squared, yeah, that kind of stuff. So I can create a function like that in the way I'd do that in C++ is I would say, so I'm getting to your question. Okay, so that's without elaborating on what the bits and pieces are. Line 16 is what we might see in a math class. Lines 11 through 14 is the C++ equivalent to that. The question, what is this representing? This is representing the kind of thing that my function is giving back. Note that you don't have to necessarily specify that in a math class. Here I have to specify that it's an integer. The question was, can I have something different than integer here? Yes, absolutely. If I'm dealing with floating point numbers, I can specify float. Or if I have a function that doesn't return anything, which seems odd in mathematics but is fairly normal in programming, you can put void or whatever. All that said, in any program you ever write, the only way, let me see, the language needs to know where your program starts. So you can have as many or as few functions as you want in an application. There's one function you need to have 100% of the time, and that is the function main. Main is what tells the language where your program begins. And that one always has to return an integer. All right. So how do I tell the computer what x is? We've kind of stolen my thunder. There is a type called integer, which just simply means whole numbers. That's sufficient right there. X is an integer. Now my compiler, I'll be sure and write out my changes. I come over here. I will use the clever shortcut I described a few minutes ago, an exclamation point G, hit enter, and now it compiles without error. I can run it, so in my current direct, let me do an ls. There it is. ioprog is the executable that I created. In my current directory, I want to run ioprog. It doesn't look like it did anything. Actually, it did do something. It created a variable called x and assigned -23 to it, and then the program ended. So not a very useful program. It's not going to make me the next Bill Gates, but it's a start. All right. So any questions on that little tiny bit that I've got so far? Okay. To the extent, just to back up slightly, to the extent that you're kind of unclear about what's this main business, you can almost look at, until you get a better understanding, you can look at what you see on the screen right now as a recipe. Every program you're going to write, at least in the first half of the semester, if you start out there, then you can't go wrong, and then you just kind of fill in the interesting stuff between the curly braces here. All right. So what are the other types that we will be dealing with? Float. So your numbers that have a fractional component, a decimal place. Actually, let me pause for just a moment. I'll leave that there. I'll elaborate on 11 in a little bit, but here I am. I'm going to print out the contents of the x variable to the screen, and then I'm going to print an end line, which just prints a line feed, carriage return line feed. I'll compile that. I'm going to run it again. -23. All right. Here's the question. What if I assign -23.99 to x? That is very close to what number? It gives me a warning. All right. So integers do not do rounding. They simply ignore any fractional component. All right. So if I say, what would probably be more interesting is that's almost 1, but it isn't. It's 0.9, right? And we just get the 0. So any fractional part simply drop. It's not rounded. So keep that in mind with integers. Float, as you would expect. Another one we're going to be using quite a bit is string. Thaddeus. Let's see, what else? So that's covering that. There's 3 of them. Another one would be. Excellent question. Why didn't string turn green? And another one I'll put as char and it turns green. The short answer is that anything that is built in to the language, any type that is built into the language will be highlighted in green. It turns out that string is not built into the language. String is something that was built from primitives of the language and bolted on afterwards, for lack of a better way of phrasing it. Meaning that whoever created the language said that this language shall have float, and this language shall have int, and this language shall have char. No one said this language shall have string. Some programmer went out there and created a string type that's very convenient to use. Now, any C++ compiler you use anywhere will have a string because it's built into the standard. It goes something like, this string type that was built is so useful, we mandate that it's included in everywhere the compiler is used. So you'll always have string, but it is not built into the language in the same sense an integer or a character is. That's the reason it's not highlighted. For our intents and purposes, just treat it exactly as you would float, int, or char. You won't, at this level, you certainly wouldn't notice any difference. A string is always enclosed in double quotes. A char is, you never hear, very rarely do I hear someone call it a char. Everyone calls it a char, but it's short for character, a single character. Single characters are always in single quotes. Strings are always in double quotes. Note that A is a string, not a character. Not because I'm putting it on this line. I mean, I'm giving it away here. But if I come down here and say, what kind of thing is that? You say integer. And I say, what kind of thing is that? You say character. What kind of thing is that? You say string. Why? Because of the single quotes and the double quotes. Yes? Okay. Single quote's always a character. Double quote's always a string, regardless of length. That covers pretty much most of what we'll use in the semester. I'll throw out a couple others you may see, but we won't be using so much. Double. So these floating point numbers aren't infinite. They do have a limit in the size of the number they can put in it. Double is, as it would imply, is twice as large. It uses up twice as much memory in the computer, and therefore you can keep even larger real numbers in there. Integer, likewise, has limits to how large a number you can put in. If you need an even larger one, you can say long int. Or not very many programmers know this, but you can also say long int if you need something really large. Okay. Again, these we aren't going to see so much this semester. I'm just making you aware of them when you come across that they are built-in types. All right. What are the rules for a string, or for a variable, excuse me? For naming them. The first character of the name is letter or underscore, period. Subsequent letters, subsequently, letters, numbers, underscore. So all that's talking is the naming of the variables. Let's say I want to create an integer. It can be, also case sensitive. Bobby is fine. Right? As long as the first character is either an underscore or a letter, then subsequent ones can be letters, underscores, or numbers. So the only thing really, the restriction is you can't start it with a number. Right, so that's not a valid variable name, starting with a number. Okay, that's all that's being said there. Case sensitive, float, pi equals 3.14, float, pi equals 3.14. These are all imposters. I think I may actually have that one. Yeah, I already have that one up there. So I'm just going to steal them and bring them down here. I guess I don't have to go through every possible combination. So all these are different variables. Let's try, I've been typing a while. So far, so good. This is something I'll say over and over again. I've actually done quite a bit of typing before going out and making sure that it compiles okay. The biggest problem that 111 students have, and it becomes more of an issue when we get to the projects, is that there's a tendency to type 100 lines of code and then we get out of the editor and we try compiling. And you've got, I don't know, 8 different problems. You've forgotten semicolons in 3 places and a couple other issues. And you just get hundreds and hundreds of errors scrolling up. And you don't even know where to begin to solve the problem. When you're writing a program, add 2, 3, 5 lines, stop, try compiling it, and don't go on until it compiles fine. If I compile and you'd get nothing but the prompt back, thumbs up, your code is syntactically fine, and you can add more code, right? Once you eliminate those problems, then add 3, 4, 5 more lines, then come back and compile. Now if you have problems, you know it has to be in the 3 or 4 or 5 lines that you just added, right? And you're going to just end up coding a lot more quickly rather than busting out 100 lines before you try compiling. So I throw that out there. All right. Spitting these out, C out, PI, 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 PI. They're all this. Let me see. That 0 there is from line 34, where I'm printing out x. 9 divided by 10 is 0 with integers. This cout statement, you can put whatever you want between the chevrons, either variables or literal text. So I can say pi equals so this right here, a comma, a space, a p, an I, and an equal. See all that's just in literal quotes here. Now when we're talking about types, what kind of thing is that? It's a string, right? I could have put that in a string variable and printed out that variable, or I could put the literal string there, or I could put the literal integer there. It just depends what your needs are. Also, what does ENDL do? End line. Let me get rid of the end line. How's that actually helping me? You'll note that this 0, which is for the x, is printed right there if I don't have the end line. You put the end lines wherever you need them. They don't have to go as the very last thing. For instance, right, I can throw a couple end lines in the middle there. All it is a character saying, go to the next line. Input is very similar to output. You just go in the opposite direction. The information always flows in the direction of the chevrons. So all of this stuff is flowing right to left, which means all of this stuff is going to cout, which stands for console out. Console is an old style word for this text screen. So output going to the console, this is console input. This is representative of the screen. Chevrons are saying all this information is dumping to the screen. Chevrons are going to the right, which means information from the keyboard is going to go into this variable. Yeah? And then I can print out, let me get rid of that, I'll comment it out. Here I can input X and then print out X. I come over here, I compile, I run it. And we note that it just pauses. So right there's my cin statement. Note I didn't have any end line, so it's right there at the end of the 4. But I can say 9987, and there, when I print out X, that's what's being shown. Okay. The very final thing, we're about out of time, but the very final thing I want to point out is these are called streams. Stream as in a babbling brook or a river. So pound include means include the information that allows us to use input and output streams. Why do they call it a stream? What did I call this program? IO code. All right, this is how the computer sees your information. When we see it on different lines in an editor, that's for us as humans. It makes it easier on our eyes. As far as the computer is concerned, this is nothing but a stream of text. So where do I begin? Here I have the words sensitive, period, new line, space, space. Let's look at that. Oops, what did I just... Sensitive, period, new line, space, space, and then int Bobby, right? It's just a stream, so that's why it's streams. Input and output is nothing but a stream of characters. So there's nothing special about new line. All right. We'll just see in lab. Yeah, I should have said something. That's just a comment, so you can put anything to help annotate and explain.
That's just a comment.
Yeah. The pound. So it depends what you're doing. If you're doing shell programming, it's a pound. If you're doing C++, it's a 2 slashes. All depends on the language.